So we're going to talk about the basic functions and their graphs. So the first thing we're going to look at is a relation. What is a relation? Well, it's any set of ordered pairs. The domain of a relation is the set of all the first components of the ordered pairs, which we typically know as the x values. The range is the set of all second components of ordered pairs, which we typically know as the y values. And then we are going to talk about functions. And functions are a relation in which each element of the domain corresponds to exactly one element of the range. So let's look at an example. So for example 1, we are looking at some ordered pairs. One is red, 3, and then blue, 4, and green, 5, yellow, 6, and brown, 5. So we are looking to find the domain and the range. So for the domain, I'm just going to write the letter D. The domain is all of the x values. So our domain will be red, blue, green, yellow, and brown. Notice I have curly brackets here. With the ordered pairs, there are parentheses. When you write this for your exam, make sure you are using the curly brackets and not parentheses to show the domain. Also be aware of that in the homework. The next part we want to do is the range. So for the range, I'm just going to write an R. It is going to be the second value, or what we know as the y values. So it'll be 3, 4, 5, 6, and then we see we have 5 again. We don't rewrite the 5. We're just going to do a curly bracket. You only write the number once. So is this a function? That's our next question. Do we know if this is a function or not? Well, remember our definition for a function is that each of our domain only corresponds to 1 in the range. Well, red, when we put it in, only got 3. Blue only got 4. Green got 5. Yellow was 6. And brown was 5. None of the x values or the domain repeat. So it is a function. So the answer would be yes. All right, let's look at example 2. So for example 2, we are given, we're going to do a part A and a part B. So first we have negative 3, 7, 1, 7, and 2, 2. That is the set of ordered pairs we've been given. We need to find the domain. Well, the domain again is our x values, so negative 3, 1, and 2. And our range will be 7. Oh, we're not going to rewrite 7 and 2, so it'll just be 7 and 2. You won't write them twice. So is this a function? Well, for each x value, there was only one y value. So again, it is yes. And why? Because we need to understand the y. There's a couple of ways you can write this. You can say the x values do not repeat. Or you could say the domain does not repeat. Either one of those would be a good question or answer of why it is a function. All right, let's look at part B. So for part B, we are looking at the ordered pair of 4, 7, 6, 10, 5, 5, and 4, 6. So again, we want to find the domain. The domain is going to be our x value. So we have 4, 6, 5, we have another 4. And notice, I'm not putting these necessarily in numerical order. You can if you want to, but it's not important. And then we have, for our range, 7, 10, 5, and 6. So is this a function? So when we look at this, if we put in a 4, we got out a 7. Oh, wait a minute. When we put in a 4, we also got a 6. If you get more than one y value when you put in one of the x values, it is not a function. These two are okay because we only have 6 coming to 10 and 5 going to 5, but the 4, we're either going to get a 6 or a 7. We don't know which one. So this would be a no. And the y would be that the x repeats. You can simplify it that way, or the domain repeats. You don't have to write values kind of thing if you don't want to. You just need to understand that that domain or that x value, that first element, repeats on this one. Here it does not. All right, so functions as equations. So if we look here, we're looking at y is equal to 0.42x plus 10.5. This is told that we are predicting the diamond production where x is the years after 2000 and y is the value in billions of dollars. So in this, we could choose any value for x. So x is an independent variable. If we pick x, we're going to get a y as an answer. So this is where it's a function. The value of y is a dependent variable because it depends on the value of x. We don't know what y will be until we choose our x value. So x is independent because we choose it. Y is dependent because it depends on whatever x is. All right, so let's go look at some functions. So this will be example 3. And we are going to solve for y in terms of x, because that will tell us if it is a function of x or not. So the first one we're looking at is we're looking at x squared plus y is equal to 4. So we want to solve it in terms of y, so we're just going to move the x values over. So y is equal to, it doesn't matter which way you write it in this case. We're going to write it as 4 minus x squared. Now, we can put in x equal to 1. If we do that, we end up with y is equal to 4 minus 1 squared. Well, 1 squared is 1, so 4 minus 1, we get y is equal to 3. So our ordered pair would be x is 1, y is 3. All right, let's pick another value. Let's go with x is equal to 2. So then we have y is equal to 4 minus 2 squared. So y is equal to 4 minus 2 squared is 4. 4 minus 4 is 0. So now we have an ordered pair of 2, 0. And then we can choose another x value. Let's go with x is equal to negative 2. So y is equal to 4 minus negative 2 squared. Y is equal to 4 minus negative 2 squared is negative 2 times negative 2 gets us positive 4. 4 minus 4 will get us 0. So here we have negative 2, 0. So is this the function? Well, for each x value we put in, we got one y value. None of them repeated, so the function is yes. So we can state that y is a function of x. All right, let's look at this for 1 second. Notice that we have y is equal to, whatever happens here, there's only one equation. And I want you to take note of that as we look at the next example. So for example 4, we are given x squared plus y squared equals to 4. Notice it's very similar to the equation we started with last time, but there's a slight difference. So this time we're going to do the same thing we did before, so let's subtract our x squared. And now we have y squared is equal to 4 minus x squared. Well, we need to solve for y. The way we're going to do that is use our square root property. So as we bring in the square root property into both sides, we end up with y is equal to, if you remember with the square root property, you have to do the plus or minus. We don't know if it was the positives or the negatives that got us this, so we have to do plus or minus that square root of 4 minus x squared. Now you cannot take the square root of this because it's got a minus sign in the middle, so don't try to take the square root. Now as we plug in a value just like we did up here, we might notice something that happens. So as we plug x equal to 1, just like we did before, we end up with y is equal to plus or minus the square root of 4 minus 1 squared. Well, y is equal to plus or minus the square root. 1 squared is still 1, so 4 minus 1. 4 minus 1 is still 3, so we have plus or minus the square root of 3. Well, that means when we do our ordered pair, when x is 1, I have the positive of the square root of 3, and when x is 1, I have a negative square root of 3. So for each x value, I end up with 2 y values. And this happens because of this plus or minus. This part right here, once you have that, tells you that you're going to get 2 answers. Because when you solve it, you'll still have 2 answers. So is this a function? The answer will be no, and it's because the x value repeats, or the domain repeats, whichever way you want to look at it. But in this case, because we're looking at actual x values, we would probably state that. All right, next thing we're going to look at is the vertical line test. So the vertical line test on a function, when we're looking at a graph, you can't do that when you're looking at equations. With equations, you have to look at the actual equation. But when we're looking at graphs, we can use a vertical line test. You also can't use the vertical line test when we were doing our functions up here with domains. You actually have to look and see if the domain repeats. You can't use the vertical line test as an answer here either. But if we're looking at a graph, we can look at the vertical line test and say, if it intersects only once, then it's a function. If it intersects more than once, not a function. So a vertical line is a line that goes straight up and down. So I have some graphs here. This one kind of looks like a football. If I draw a vertical line, it doesn't matter where you draw it as long as you actually touch the graph that's actually being drawn. So I can draw a vertical line right here. I could have drawn the graph over here, or the line over here. I could draw it here. It doesn't matter where. When I do that, I hit once and I hit twice. So that tells me that y is not a function of x because it hit more than once. It's not a function, so our answer would be no. With our hyperbola here, we can look at this and go, oh, if we draw a line, we're going to hit once and twice. So the answer is no. Now here is a linear line here, and if I draw a vertical line on it, doesn't matter where, I only hit one time. So is it a function? Yes, it is. Here is a parabola. With our parabola here, as I draw my vertical line, doesn't matter where, I will only hit my function one time. So yes, it is a function. So this works with graphs. It will not work with the types of equations we have done so far, or the functions that we have done. All right, so let's go look at another example. So example 5. So in example 5, we are going to evaluate a function. So if we look at the function of f of x is equal to x squared plus 3x plus 5, remember that f of x is the same thing as y. So whenever we're looking at an f of x, it's just like y is equal to. So let's find f at 2. So that means wherever an x is, we're going to plug in a 2. That's what that f at 2 means. Wherever x is in our function, we'll plug in a 2. So that means we have 2 squared plus 3 times 2 plus 5. So wherever the x was, I plugged in a 2. So 2 squared is 4. 3 times 2 is 6 plus 5. So 4 plus 6 is 10 plus 5 will get us 15. All right, let's look at another one. Using our same function, we're going to do f at x plus 3. So that means we have x plus 3 squared plus 3 times x plus 3 plus 5. So every place that x was, it now became x plus 3. So x plus 3 squared, well, we need to multiply that. First of all, you need to remember that when you're talking about x plus 3 squared, that's the same thing as x plus 3 times x plus 3. You can work that here, or you can work it off to the side. I'm going to work it off to the side so we can kind of follow what's going on and not get complicated into the rest of it. So this is just like foiling, and you're just going to multiply it. I usually like to cover up the second part. So x times x is x squared. X times 3 is 3x. Now let's look at the first part of our, cover that up. So 3 times x is 3x, and 3 times 3 is 9. Combining like terms, we get x squared plus 6x plus 9. So now I can come back over here and rewrite that the x plus 3 squared is x squared plus 6x plus 9. And then I can do the rest of my equation. So 3 times x will get us 3x. 3 times 3 is 9, and we'll bring down our 5. Now it's about combining like terms again. So we have x squared. I have 6x plus 3x. That will get me 9x. I have 9 plus 9 is 18. 18 plus 5 will be 23. All right, let's do one more. So if we find f at negative x, that means wherever x is again, we're going to plug in a negative x. So we have negative x squared plus 3 times negative x plus 5. So negative x squared, well, that's negative x times negative x. That will be a positive x squared. Notice when I'm plugging those in, I am putting parentheses around them, so I make sure I take the whole thing. 3 times negative x will get me negative 3x plus 5. And that's all we have to do on that one. There's nothing to combine as far as like terms, so we are finished with that one. All right, let's go on to example 6. So for example 6, we're going to graph a function. So the function we're going to look at is f of x is equal to 2x. So to graph this, we're just going to pick some points to use, and we're going to make a t-chart. It's a t-chart because it looks like a T. I'm going to put x and y. Remember, y is the same thing as f of x, so it's just easier to write y. And I'm going to pick some values. When I'm graphing, I try not to pick the values exactly next to each other because when I do, that sometimes they'll be so close it's hard to see what's going on with the function. So I'm going to pick negative 2, 0, and 2. You don't have to pick those. You could have picked like negative 1, 1, and 3. But 0 is always easy to plug in. And in some cases, you can use negative 1, 0, and 1. Sometimes it just gets so close, it's hard to see what's happening with the graph. So to plug it in, we're doing the same thing we've been doing up here with our equations. We're going to plug in negative 2 wherever x is. So that will be 2 times negative 2, because it's 2 times x, and that gets us negative 4. Now we have 2 times 0. Well, anything times 0 is 0, so that will get us 0. And then we have 2 times 2, which is 4. So that will be 4. So we just plug these into our function. So let's go ahead and graph this. I don't need a lot of numbers, but I know I need to go clear up to 4 for this. So we've got 1, 2, 3, and 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and 4. I'm going to draw my little arrows. This will be my x value. This will be my y values. All right, so when I go to graph this, my first point is negative 2 for x and negative 4 for y. So it's going to be right down here. Then I have 0, 0, and then I have positive 2 up to positive 4. So I'm drawing this by hand, so it doesn't always look as great as if you're drawing it on graph paper. But that's what our graph looks like. Is it a function? Well, yes, because I could draw a vertical line at any space on there, and I'm only going to hit it once. But we're going to take this same function and change it slightly. We're going to call it g of x, and we're going to do 2x plus 4. So let's see what happens to our function. If you notice, the only thing that's changed, we called it g of x, so it's not the same as f of x, but we've added 4. So we're going to do x and y in our t-chart, just like we did. I'm going to pick the same point so I can see what happens, pick the same values for x. And let's see what happens to the y value. So we're still plugging in that negative 2, and then we're adding 4. So 2 times negative 2, that will get us negative 4 plus 4. That gets us 0. So for 0, I get 2 times 0 plus 4. Well, 2 times 0 is still 0, plus 4 will get me 4. So 0 plus 4 equals 4. And then 2 times 2 plus 4. 2 times 2 is still 4, plus 4 will get us to 8. So let's see what happens when we graph this one. Oh, I gotta add my values here. So negative 2, 0. So at negative 2, we're at 0. 0, we're at 4. So 1, 2, 3, 4. And at 2, we would be up way up here to 8. I'm not going to draw the 8. I'm just going to go ahead and draw my line with those 2. You really only need 2 points to draw the line. I'm just using the 3 to really make sure. Because if you make a oopsie and you only have 2 points, it's easier to see with a third point that you have a straight line instead of a curved line or something. So what do we notice about the two graphs? Well, with the equation, the only thing that changed is we added 4. And if you notice, for each x value, it went up 1, 2, 3, 4. 1, 2, 3, 4. And this one would have gone up as well, up to 8. So the graph of G is shifted four units vertically is what we will call that, because it's going up, so it's vertical. This will come in to help you later on as we learn about transformations. All right, so for our next functions, I've got some graphs here. We want to determine the domain, the range, and the x-intercept, the y-intercept. So we're looking at the graph and trying to find some certain things. So this will be example 7. Set that up there just as well as we can. So example 7, first thing I want to find is the domain. So with your x values, when they are going, both sides are going like this, might be easier this way, or going this way, that means that it's, because it's continuing on forever, our domain will be all real numbers, or if we're doing interval notation, it's negative infinity to infinity. Now our range, in this case, it starts from the bottom. So your domain, you're going to start from the left and go to the right. That's the x value. So it's going, continuing on and continuing on. For the range, you're going to start from the bottom, the smallest numbers, and move up. So from here, because the graph keeps going, it's going to be negative infinity. As we watch it go up, 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 we're looking to see where it stops. Well, it stops at 4. It actually touches the 4. So our range will be from negative infinity, it goes up to 4, and it touches it, so it gets a bracket. Now for the y-intercept, we are looking to find the y-intercept. Well, this is where it intercepts the y-axis, so the y-intercept is at 4. The x value is 0 whenever you're looking at a y-intercept. For the x-intercept, we actually have 2 of them. It's where they cross the x-axis. So they intercept at negative 2 and positive 2, and the y values will always be 0. So negative 2, 0, and 2, 0 will be your 2 intercepts. And let's find the graph at f at 1. Where does the function at 1, that means the x value is 1. So when x is 1, what is our y value? It is 3. So the function at 1, or x equal to 1, equals the value of 3. All right, let's look at our next graph. So on the next graph, we're going to do the same things, but it's a little bit different. So let's call this like part A, and we'll call this part B. So for part B, we're looking again for the domain, and we're looking for the range. So the domain again is our x values. So if we're starting from the left, we come in, we hit negative 2. It is a closed circle, so it includes it. And we go all the way over, and it stops at 1. That's the highest x value, and it is also a closed circle. So it will get a bracket on each part. The range will start from the bottom and come up. The first value that the graph hits is going to be where y is equal to 0, and it goes up and stops where y equals 3. Again, it has closed circles, so it will include them, and when it includes them, we put a bracket. Now we're looking for, let's look for the x-intercept, and then we'll find the y-intercept. So the x-intercept, well, it's touching the x-axis right here at negative 2, so it will be negative 2, 0. And for the y-intercept, it's actually touching right here at the 1, so it will be 0, 1. So we can use this to find our values, our functions, just like we've done before. All right, let's go look at the next graph. Let's call that one part C. So on this one, we have an open circle, so that changes things a little bit. So for our domain, because it is an open circle, we are cruising along, and we end up at 2. So we're starting at negative 3 and stopping at 2 for our x values. But because it's an open circle, it will get a parenthesis. So it'll be parenthesis negative 3, 2. 2 has a closed circle, so it gets a bracket. And for the range, we'll come up from the bottom. First y value we touch is 1, and it stops at y at 2. So that means the 1, it has an open circle, so it will get a parenthesis, and it'll go to the 2 with a bracket. For the x-intercepts, It doesn't touch the x-axis at all, so we will write none. For the y-intercept, it crosses right about here, so you have to kind of guesstimate. If we were on a test, just give me a rough answer. That looks about 1.5. So we're going to go that it's 0 for the x value and 1.5 for the y value. All right, we have one more example for this section. Example 8. So a company that manufactures printers has fixed costs of $5,000. It costs $500 to produce each printer. The total cost for the company is the sum of its fixed cost and variable cost. Write the total cost, C, as a function of the number of printers produced, X. Then find C at 10. So we need to write a function. So this will be example 8. So C of X, we are told, is the fixed cost plus the variable costs. That's what it's going to be equal to. So what is our fixed cost again? Well, it tells us that it has a fixed cost of $5,000. So fixed cost at $5,000, and then the variable cost will be $500 to produce each printer. So $5,000 plus the variable cost will be $500 times every printer we produce. We just don't know how many we're going to produce each time. So as we're working this, that would be our function, and then it asks us to find C at 10. So that means, again, wherever x is, we're plugging in 10. So that'll be 5,000 plus 500 times 10. So that's 5,000 plus 500 times 10 will get us 5,000. So it will be 10,000. And we're talking about dollars, so we can put a dollar sign. Always note that your dollar sign goes in the front and not the back.